Welcome to this episode of Eureka, and we are going to have a very interesting conversation with Professor Krishnan Balasubrahmanyam, who is the head of Center for Nondestructive Evaluation, a center in Indian Institute of Technology, Madras. Before we start this conversation, let's take a quick look at his brief profile. Keep watching Eureka.
A mechanical engineer by profession, Professor Krishnan Balasubrahmanian has been involved in the field of non-destructive evaluation for more than 33 years, with applications in the fields of maintenance, quality assurance, manufacturing and design. He is currently a chair professor in the Department of Mechanical Engineering and also serves as the head of the Center for Non-Destructive Evaluation, which he founded in 2001. He received his undergraduate degree in mechanical engineering from the University of Madras in 1984. He then graduated from Drexel University with a MS degree in 1986 and a PhD in the year 1989. Before joining IIT Madras in 2000, he was employed as tenured associate professor at Mississippi State University. His areas of research interests include non-destructive evaluation, in-process monitoring, structural health monitoring, and applied data analysis. Professor Subramanian and his team has developed a system to clean cotton before it is spun into yarn by using inaudible sound waves to pick out unwanted material, and also developed a technology to detect and inspect railway tracks from cracks and corrosion. He has been instrumental in the incubation of several startups, including Dhwani Research, Playance Technologies, Likes, and has jointly developed several new products through these companies. In recognition for his outstanding contributions to research in the field of non-destructive evaluation, he was conferred with the Roy Sharpe Prize by the British Institute for NDT for the year 2012. He was also conferred the DRDO Academy Excellence Award for 2015. In 2018, he was bestowed with the prestigious Abdul Kalam National Technology Innovation Fellowship by the Indian National Academy of Engineers and the Lifetime Achievement Award by the Indian Institute of Technology, Madras.
Thank you, sir, for being with us. It's a great opportunity. It's a very wonderful place. We come to know that lots of work going in Indian Institute of Technology, Madras, in addition to training students. And your center is working on a very important area which is called as non-destructive testing or evaluation. So let me start with this name itself. The name itself says a non-destructive evaluation. So which means that perhaps there should be a destructive evaluation, and why this difference and what does it mean? Can you elaborate?
Yes. Thank you so much for giving this opportunity, and welcome to IIT Madras. The field of non-destructive evaluation or non-destructive testing has been around for ever. For instance, whenever way back, whenever your grandmother or somebody was trying to select a pot for storing water, all you did was you used to knock on it.
Yeah, when they pick it up, knock, and then
yes, exactly, and then you listen to it. And then this gave them an idea that whether this is a good pot or a pot with a crack in it.
Okay.
Whenever you select a coconut, you do the same.
Yeah.
You knock on it and you listen to it.
Shake it, yeah.
Or shake it and you listen to it, right? So what are you doing here? You are trying to find whether this particular product is a good product or a bad product. But suppose I say, let us break it, let's drop it. If it breaks, then I will not buy it. If it does not break, I will buy it. That would be the destructive way of doing things.
Okay.
While by knocking or by shaking, if you find it, then that is a non-destructive way of evaluating the product's integrity. Now, I will just take this a little further. Almost every one of you have been experiencing the non-destructive evaluation or non-destructive testing in your lifetime. Anybody who has had an X-ray done, or if you have gone to a doctor, the minute he puts a stethoscope on you, he is trying to find out whether your heart or your lung is in good shape.
Okay.
And this is another way to do non-destructive testing.
So the non-destructive testing is also happens in medical field, but whereas of course you are looking at more at mechanical.
Exactly. Now let us say that I have to do this for an airplane. Now an airplane cannot come to the diagnostic lab. So here the diagnostic instrument like a stethoscope
Should go there.
should now go to the aircraft. There should be some way by which you should be able to go and place it at different locations and find out if the plane is healthy or not healthy.
Now let me ask you one question. I mean, many of the examples that we said, I mean, let's say for example what we, let's have a grandmother or others used, you know, tapping the pot or shaking the coconut or using a stethoscope. We are talking about sounds being produced by the object, right? So is it the only way that we do the non-destructive testing, meaning that is it the only the acoustics that is important, or there are many ways in which you can do it?
Going back to the example I talked about, when you go to a diagnostic clinic, they use X-rays.
Yeah.
Now X-rays is electromagnetic spectrum. Anybody who has done high school physics understands where the electromagnetic spectrum you have the X-rays. So what we do is we can look at every part of the electromagnetic spectrum as you have learnt it in high school.
Okay.
That means radio waves. You can look it at from the infrared imaging spectrum. You can do X-rays. You can do even gamma rays. So anything that allows you to explore and find more information about any engineering component and tell the health of that engineering component without in any way changing or reducing its effectiveness, we would call as non-destructive testing.
Okay.
If you were,
so imaging is another way of doing, not only sound but
another way to doing it also. So X-ray is an image.
Yeah.
Right.
So see, we use X-rays when with regard to body.
Right.
Because if you want to look at the soft tissues and the bone.
Exactly.
I mean, the X-rays can give you the shadows. So that's what we are looking at.
Exactly.
So if you are going to use, let's say for example, gamma ray, where would you use it? Or if you are going to use infrared rays, where will you use it?
So gamma rays are high energy radio waves that penetrate harder materials. Such as steel or even harder materials like tungsten. In order to do that, you need to use higher energy levels to penetrate. And so we use radioisotopes to do that. So which means that you also have to not only be able to penetrate the components, but also be able to tell whether there is a crack, for instance, or if there is a corrosion that is going to affect the life of that particular component.
Okay. So if you are going to talk about infrared rays?
Exactly. Infrared is one of the very important technology that we use.
Okay. So now we are looking at sound and also imaging.
Imaging.
For non-destructive testing. Any other technology that we use?
So the sound is in the acoustic spectrum. The infrared imaging or the X-ray imaging or the electromagnetic, they are on the electromagnetic spectrum. So these are the two major what we call modalities that we use to examine and to find out what is inside by not invading the inside. So a destructive method will be that if I will to do a surgery on you and I find something wrong with you, then that will be a destructive way, because there is definitely making you rendering you temporarily ineffective. Okay. If we can do that without in any way invading into you, that's okay. For instance, suppose I use endoscopy. So optics is another way. Optics is another part of the electromagnetic spectrum. So if I would do endoscopy, then that is still hopefully non-invasive, because as long as you can walk out of the after that without any serious after effects, then that I would categorize as a
almost
non-destructive way of doing things.
Very, very interesting point, and this is where we are going to take a small break. We'll continue this conversation. Let's take a very small break. Keep watching Eureka.
शहरों की आबादी लगातार बढ़ रही है। लोग बेहतर भविष्य की तलाश में लगातार यहाँ पहुँचते और बसते रहते हैं। आज यही हमारा सरोकार है, शहरीकरण बनाम पर्यावरण।
जो भी हम विकास करते हैं, विकास में पर्यावरण का पूरा ध्यान रख कर करते हैं। जो हमारी जो 7 कॉलोनी बननी है, ये पूरी तरह से जीरो वेस्ट है। वहाँ से एक भी डेब्री बाहर निकलेगा, सारा सारा वही कंज्यूम किया जाएगा, सारा सॉलिड वेस्ट, सारा लिक्विड वेस्ट वहीं कंज्यूम हो जाएगा, सारा का सारा वहीं पे उसको प्रोसेस कर जाएगा। वहाँ पे रिन्यूएबल एनर्जी का भी प्रयोग होगा, पूरी तरह से ग्रीन कॉलोनी होगी।
मेट्रो बन गया, सब लोग प्यार करते हैं, मैं भी प्यार करता हूँ, उसी से चलता हूँ। लेकिन जब पिलर पाइलिंग हो रही है फ्लड प्लेन में, तो हमें देखना है कि सबसॉइल और डीपी के ऊपर पंचर कर रहे हैं क्या।
पेड़ एक जिंदा इंसान है जो बोल नहीं सकता। ये पेड़ वाटर लेवल भी रिचार्ज कर रहा है
जी।
ये पेड़ नॉइस पोल्यूशन भी कंटेन कर रहा है।
देखिए सरोकार सिर्फ राज्यसभा टीवी पर।
Welcome back to Eureka. We are having a wonderful conversation with Dr. Krishnan Balasubrahmanyam, who is the head of Nondestructive Evaluation Center at Indian Institute of Technology, Madras. Before the break, we were talking about this discipline called non-destructive testing, and then how from time immemorial to modern technology. That's very essential because we don't want the technology or the product to fail.
Exactly.
So now let's come to your center. I mean, this is a center that has been established in this institute, and I'm sure, I mean, this center would have taken lots of very interesting projects which have a societal benefit. Can you tell us some of the interesting projects that you are involved?
Yes, so there were, of course, over the last 18 years of the existence of the center, we have had many exciting efforts. We have worked very closely with many industries, not only in India but abroad also. And so there is so much to cover, but I will just give you a couple of examples.
Yeah.
One example is working with the cotton that comes into your shirt.
Okay.
Every one of you likes cotton shirts.
Yeah.
Now, the way the cotton is harvested is in the farm,
Yeah.
and then it is going through a process called ginning, that where the seeds are separated from cotton, and then they are packed into what are called bales. They are like compressed cotton, and then they sent to the next phase, which is called the spinning mills.
Yeah. So where they spin into small threads.
They spin into nice bundles of threads that you normally will see it, and they're big spindles that they're used. Now, what happens is that when the harvesting happens and during the transportation of the cotton to the spinning mills, there are a lot of contaminations that happen. For instance, you have pan parag foils, you have chocolate wrappers, you have lace chips wrappers, you have jute fibers, you have the polypropylene fiber that are used in the bags. All of them get mixed up. And now, if for some reason they become a part of the thread, then you will see that in your shirt, because that particular fiber is not going to change color when you dye it.
Not only that, maybe it may break.
It may break, it certainly you will not buy it.
Yeah, certainly. Not.
Okay. So now the question is, how do they handle this? So many years ago when the industry came to us, what they used to use was, they used to use several employees who will sit through this hazardous material and sort of handpick these.
It's like, for example, removing the stone from your rice.
Exactly. So this exactly, and it's very tedious. It is hazardous because these small fibers, when they smell when they get into your system, obviously can create medical problems for these employees. And of course, profitability for these companies is a big issue because the margins in these industries are very, very small. So how do we help them? So what we developed was, over a period of 2 years of research, where the small industry from Coimbatore, which is a hub of cotton belt of southern India, and us, we worked together very extensively, and we found out that one way to do is by using ultrasound as a mechanism.
Okay.
So the way we did that was simple, that cotton being very soft absorbs sound waves when you send a sound wave. These fibers, these chocolate wrappers, actually don't absorb, they actually reflect. So then we created an array of these generators of sound waves, and as the cotton is flying past, it will send the sound wave. If there's only cotton, then the sound wave go through the cotton.
Okay.
In case there is a contaminant, immediately there's a sound wave that comes back from that region, and then we had this what I call air jets that will remove that particular piece alone.
Okay.
Automatically. So we actually, with collaborating with this small company in Coimbatore, we created a complete product line, and we have implemented that in several countries. A lot of the installations are in India, South, North, Bangladesh, even Pakistan to some extent, but most importantly a lot of European countries. And the idea here is that these companies actually saved a lot of revenue and probably saved a lot of jobs. So this is one example where
so basically this research actually went into making a real product, right?
Exactly.
And it's now in the ground.
Yes, yes, we have I think the company sold hundreds of these instruments and made, as I said, made processing cotton or made the spinning mills more economically viable and survivable. Plus
also your contribution to the railways, particularly your collaboration with Southern Railways, is something that people say is making rail travel safer in India.
So as I think being one of the most ardent user of Indian Railways, I must say that I always worry when I travel in a train because we travel on train tracks. These train tracks actually can potentially develop what are called as cracks. Now this happens due to many reasons, because we load the, we have so many trains going every day. So they actually develop cracks, for instance. There is also corrosion because rainwaters and many other fluids actually accumulate in these train tracks and start to corrode these particular train tracks, and then that leads to again failures. So there have been, as you can imagine, there have been a few very visible and very well reported accidents. But what is not reported is that there are many accidents that happen with the cargo goods trains, which do not necessarily get reported. This is not a phenomenon only in India. This is a phenomenon worldwide. Just want to share with you that the American Railroad reports that there is one accident per day.
Okay, somewhere in
US alone.
Okay.
Okay, and for them the concern is that the cargo can be a hazardous gas or hazardous fluid, and that actually creates evacuating neighborhoods. In India we are more worried about saving lives because we have more passenger, equally a large number of passenger trains. So what we had developed, thanks to a great, good collaboration with the Southern Railways, we actually developed a high-speed inspection system.
Okay.
To look for cracks, to detect these cracks, and to actually alert the railways that there is a crack in a particular section.
How does it happen actually? I mean, earlier this gangmen used to walk around.
Exactly. Even today, today, believe it or not, the gangmen do walk around, and they actually use a handheld device, which is fairly tedious, slow, and then the reporting is primarily done with manual notations. There are many difficulties. One is that because today the availability of the train tracks for inspection has reduced significantly because more trains are running. So less time for you to inspect. Second is, as more trains run, the damage is accumulating much faster. All right. And now another biggest difficulty that the railways are facing is that the gangmen are not safe because many times during foggy conditions or night conditions, they've been run over by trains, and we don't have yet the technology to prevent that. So in these scenarios, we want more automation. We want to find out how to do it faster, cheaper, better, and also to make sure that we don't miss a single crack because no life is expendable.
So how does this your machine work now?
So basically, we use ultrasound.
Okay.
So what we do is we send an ultrasonic wave that is generated on the surface of the rail, and then it travels through to the bottom of the rail. If there is no crack, then it will just keep going.
Okay.
If there is a crack that is encountered, because there is a change in the material, you get a small reflection of the sound waves.
Okay.
And now the question is, and the challenge here is now very different. When you start speeding up this process, then your electronics has to be very fast.
Because if I am checking here and I am sending, by the time it comes back, if I had
Yeah,
moved,
but the wave is not going to come back.
Come
so
back,
you got to
yeah.
be smart enough to do it very quickly. Second is the volume of data that you get is enormous.
Yeah, and you can't sit each and every point to check.
Any of you who own a computer will know that what I mean by 1 megabyte or 1 gigabyte.
Yeah.
So 1 kilometer at certain rates of we have to take data every 4 millimeters.
Okay.
So 1 kilometer can give me almost 1 terabyte of data.
1 terabyte of data.
Yes, up to 1 terabyte of data.
Okay.
And so how do you analyze? I mean, now you're talking about how many hundreds of kilometers.
Yeah.
So you're taking hundreds of terabytes of data. So software becomes very important. This is where our challenge was. So we have developed complete software packages, and we have actually done more than we with Southern Railway over a period of 4 years did about 1,400 kilometers of tracks. We did it in different conditions: day, morning, 2 a.m.
Okay.
afternoon, 4 p.m.
To see that it can work in all kinds of conditions and not just only in idle conditions.
Exactly. And so we have developed a prototype system and delivered to the Southern Railways, which they then continue to use it for quite some time.
So where is this technology now? I mean, the prototype has been developed. I mean, are we looking
So
at...
we are actually discussing with the railways to see if we can now make it into a full product, and then maybe the railways can use it more regularly. So there is some certifications that has to be done before this becomes something that you see on a common daily process, but that's being worked out.
We are also told that you are closely working with the nuclear power plants in India to make it even more safer. So can you tell us what exactly you are doing there?
Sure. We work in the area of energy in general. Now, there are two issues. One is safety, second is productivity.
Okay.
Now, we want to make these plants run without failures. So if there is a sudden failure in one of the power plants, obviously you will see that there is a power shutdown in your house. This is a big problem. Second is that we don't want no casualties due to any accidents. So what happens? Now again, just like a human body, your human body becomes old, your bones become old, your tissue become less stiff. Similarly, any material, whether it is made of stainless steel or whether it is made of plastic, they all also age.
Yeah.
In addition, now in these power plants, you are putting them through very high temperature cycles. Sometimes the temperature can be as high as 1000 degrees, 1200 degrees Celsius. Very hot temperatures. In these conditions, although we select materials of the best kind, they don't necessarily behave the same way over continuous usage.
Yeah. So when the temperature is high, maybe it will expand and then it will contract. So in this expansion and contract itself will create.
You have what's called a fatigue, thermal fatigue. Okay. So a simple example will be if you take a gem clip and if you want to break it, you will not pull it. You will bend it 3 times and it will break. This is called fatigue. This is a common phenomena. There are other phenomena also, but fatigue is a good example. So although we make materials, all these components are made of materials that are very fatigue resistant, you certainly cannot make them ideal. And also in these processes there are variations. So the question is, how can I make this safer and how can I make this more productive? So non-destructive testing plays a very huge role. So we do use non-destructive testing tools, whether it be X-rays, whether it's ultrasonics or electromagnetic sensing, to ensure right at the manufacturing stage, whenever a power plant is made, say a BHEL for instance makes the power plant components. So we actually do X-rays or ultrasound at the stage of production to make sure there are no defects in these components, so that we make sure that it's safe for you to deploy. So what we need to do is to periodically assess the health. Just the way you and I go to doctors on a regular basis, we need to do the same. And in order to do the same, we need to develop technologies that are again cheaper, that can go into these not so friendly environment and be able to get the information as quickly as possible. And then how do we interpret the again large volume of data and make a decision? For instance, you go to a doctor and the doctor says there is some problem with you. Would you immediately go for a surgery? very likely you will want a
Second opinion.
second opinion. So what we will do is we will do it with one technology, and if we see there's a potential problem there, we won't immediately say, okay, let's shut down the plant and let's rip it apart, because that will lead to lack of productivity. So we will use another technology to confirm the findings of the first technology. And once there is a confirmation, then we have to say two things. How long can I survive before I do the surgery? Can I take medicines? Is there something I can do, equivalent of a medicine? Can I unclog my pipe, or can I just put another patch around this pipe and survive till when I can afford to shut the plant down?
Okay, so these are all kinds of decisions one can make through
Yes,
this.
exactly. Yeah, very similar to what you do with your health. You know, you can do a stent, you can do angiogram. Very similar interventions.
Okay, now let me shift to a different area and talk about those issues. You belong to Indian Institute of Technology, one of the premier institutes in this country, which is proud to produce hundreds of students with human capacity. That's I think one of the major strength of these institutions. And there have been lots of views that lots of works are happening here, but it's not getting translated into field. So how does Indian Institute of Technology, or for example, this institution, takes that challenge and addresses it?
So we must understand where we want to position academic institutions like IIT Madras. On the one hand, we are looking at academic institutions to actually transform young minds, and that I think we have been doing very successfully. And I think over the last 50 plus years of our existence, we have transformed probably close to 50,000 to 60,000 young minds. In addition, what we also do is what's called frontier research. So here we actually publish in the best journals, and these publications are read by everybody in the world and sort of critiqued, and so we are part of the research community with some of the best in our field, and which is very critical, and that kind of is one of the main goals of and mandate of an institution like IIT Madras. Now, in the last 20 years or so, more than before probably, but more importantly in the last 20 years, IIT Madras has recognized that we must also do more. So we, in the words of my director, want to be also focusing on what's called translational research and transformational research. When I say translation research, I've kind of given you some examples already of what I do. So how do I help the industries in India? How do I help Department of Defense make our borders safer? How do I make
specific individual questions? I mean, you are finding solutions.
We are working with the various entities around the country, whether the Department of Defense, whether it is space, whether it is energy like power plants, and nuclear industries. We are making a small difference, and we work by creating value in our research. The final is transformational research, wherein how do we influence the society at large. So there are many things that are happening here. I think hope you will be able to cover a few of them, whether it is clean water, whether it is affordable housing, whether it is available healthcare, or making a difference in one's life, whether it's at an individual level or society level. IIT Madras has making a big difference. IIT Madras has been very active in the startups and incubation programs, which is all done within the campus for the last 15-20 years.
That's a very interesting point. And we had a very wonderful conversation with you in this show, and it's been very informative, very thought-provoking, and also feels proud that we are able to face some of the challenges that India is facing today, be it in railways or in power sector. Thank you for this time, and keep watching Eureka. We'll come back with a very interesting conversation next week, same time.